Today we are going to start with IGCSE Physics, Paper 2, Variant 2, February-March 2025, okay? And this is MCQs paper, 40 questions over there. For the question number 1 over there, he is saying that the diagram shows the three forces acting on an object. What is the magnitude of the resultant force acting on the object over there? So resultant, if we go with, like this is 1 Newton, this is 10 Newton over there. This is 1 Newton, this is 9 Newton. It means 9 minus 1, both are in opposite direction. So we will take 8 Newton as a resultant. So 8 Newton is like this and 6 Newton is like this. So according to Pythagoras theorem, if I go for it, then I will say 8 square plus 6 square root to give me 64 plus 36. After that, it is 100 now. 100 square root, it giving me 10 Newton force over there. So option B is fine for it. After that, go to the question number 2 over there. Which road defines speed and velocity over there? Distance traveled by given direction. That is this velocity, not the speed over there. And distance traveled per unit time, speed in given direction. Yeah, that's option B is fine because velocity is a vector quantity and speed is a scalar quantity. When you are saying speed in a given direction, then it is a velocity over there. And we are taking it. Okay. So move to the question number 3 over there, where he is saying that the graph shows that the journey of a motorcyclist, okay, which section of graph the time when the motorcycle is stationary at the some traffic lights over there. Mostly we stop over there at the signals over there. And when it means at that time speed is 0 and there is no area under graph, that is the section C over there. Should be taking into account. B is traveling decreasing speed, A is having some constant speed, D is having increasing speed, and C is at rest at some signal for some time over there. For option number 4, question number 4 over there, he is saying the acceleration of free fall of on the moon has 1/6 of the value of the Earth over there. And on Earth, an astronaut measures its weight is 60 kg. Okay, which row describes this over there? Weight is 60 kg. 60 kg, then it means it should be 6.1 Newton, 6.1 Newton, 590, 59, 9.81 should be taken. So 590, 9.81 should be fine for it by multiplying according to Earth. And 60 should be multiplied by 6. 6 times dividing 590, because mass is not changing on the surface of Earth and surface of Moon over there, because it is a constant quantity on both planets over there, on Earth and Moon over there. So it is option D will be fine for it, like this, because you have done 60 multiply 9.81 to get 590 over there, and then you divided 590 divided by 6, like that. You have got approximately equal to 98 over there. So option D is fine for it. Go for question number 5. The load extension graph for a material is shown. Which point indicates the limit of proportionality? And the limit of proportionality is going to show the graph as straight line over there. So for that purpose, when the graph is straight line, is related till only the point A over there. This is limit of proportionality. After that, it is not going straight. It is going to show some curve over there. It should be straight like this. And limit of proportionality means we say stress and strain are directly proportional to each other. Strain directly proportional to each other. So at that case, we can say here, when stress and strain are directly proportional to each other, is showing the graph, straight line over there. This is also being taken. Force applied is directly proportional to extension over there. According to Hooke's law, F is equal to Kx is mostly taken. Graph should be exactly straight line if it is following the criteria over there. After that, he is saying an object of mass 4 kg is moving with velocity 3 meter per second in a straight line. What is the momentum? So 4 multiply 4 kg is moving with velocity of 3 meter per second in a straight line. What is the change in momentum over there? So just knowing the formula, momentum is equal to mass multiply velocity. So mass is 4 multiply 3, which is equal to 12 kg meter per second, or Newton second can be taken it over there. So it is 12. Option C is there, will be fine for it. Here he is saying a tall cylinder is partially filled with liquid, and a tall cylinder is partly filled with two liquids which do not mix. The two liquids have different densities. A student measures the pressure due to the liquid at different depths. Okay, means P is equal to rho GH should be taken, which graph shows that the liquid pressure varies between the position P and Q over there. So pressure and depth is given in this form, in this form, in this form over there. Then we say how it is going to show that how pressure is going to vary. Then for the low density, it is as the depth is increasing, it is going like this. Then it is increasing because high density is going to increase because pressure is equal to rho GH. And when density is low, pressure is low. When density is high, pressure is high over there along the depth over there. Option B is fine for it. Okay, now he is saying a tennis ball with momentum 2.3 is struck by a tennis racket. The racket causes the direction of motion of the ball to reverse. The racket exerts an average force of 1500 Newton during the impact of the ball. The racket ball are in contact for 0.024 seconds. What is the magnitude of the momentum of the ball as it leaves the tennis racket over there? So it is reversing the direction. So I can say here mv plus mu is equal to force multiplied time over there. Why I took plus? Because the direction is changed over there. If direction is not changed, then I say final momentum minus initial momentum over there. So for this case, I will say here 1500 multiply 0.0024. Let's take some calculator over here. Okay, 1500 multiply 0.000024 is equal to 3.6. So it is 3.6 minus 2.3, and I'm getting here calculator. Okay, that is 3.6 minus 6 minus 2.3, which is equal to 1.3. So option A is fine for it. Option A is 5.8. So it is 1.3 kilogram meter per second over there. Kilogram meter per second. All right. Let's move to the question number 9 over there. A car is traveling at a speed of 8 meter per second. Kinetic energy stored is 32,000. Kinetic energy of the car when its speed is 16 meter per second. Okay, a car is traveling speed 8 meter per second. Kinetic energy stored in the car is 32,000 joules. What is the kinetic energy stored in car when its speed is 16 meter per second? So if I say 8 meter per second, 32,000. Speed is doubled. It means it should be go for 4 times over there. So 32,000 multiplied by 4. Uh, 32,000 multiplied by 4 equal to 128 triple zero. 128 triple zero. If I take a round off, then I can say it is going towards this D over there. What I did basically, as I know, kinetic energy is equal to half mv square. If it is 8, it is doubled. It means 2 into v into whole square. So it is 1 by 2. M is still there. How much the kinetic energy increased? Because of this square, it is 4 times. So I just multiplied 4 with 32,000, which was shown to you as 128 triple zero. I rounded it off and I got the value of 1030 triple zero joules over there. Okay, after that, he is saying the sun is not a primary source of energy for which source over there? Okay, oil, tidal, wind, wave. So tidal is due to the gravitational pull of moon over there. So sun is not playing any role. Gravitational pull of moon on the surface of ocean over there. Tidal energy is produced. So moon, sun is not playing any primary role over there. An experiment is done to compare the rate of conduction of thermal energy in metal and plastic spoons. An ice cube is placed on one end of each spoon of each side is heated. Okay, heat, plastic spoon and metal spoon. Metal spoon will going to melt this first over there. So we can say here the ice cube would melt quickly on the metal spoon, and metal is a good conductor. That is a good option. So I am not going to discuss the other ones because it is going exactly to stand over there. For a student to determine the efficiency of 4 different electrical devices, the teacher knows that one student has made a mistake in calculation, which value for efficiency is not correct over there. So if we say efficiency can be maximum 100%, like probability can maximum 1 over there. So 102% efficiency is not possible now. So this is the right option for this answer over there. Here he is saying a sample of a gas is sealed inside a container of fixed volume. The temperature of gas is increased. Okay. Uh, Temperature of gas is increased. Gas is sealed, fixed volume. And which statement explains why pressure of gas increases? The gas particles collide with the walls of container more frequently as temperature is increased. Definitely, this will happen. No need to expand the other one. The mass of gas particle increases. No way. Number of gas particles in container increases. No way. And the time between the collision of gas particles increases. Like it's slow down. It's not the right option for it. Okay, after that, he's saying a student does an experiment to determine the specific heat capacity of metal box. He uses energy supply 12 kilojoule, temperature change from 20 to 45. Mostly it is taken in Kelvin if temperature is involved, but here it is only the difference, so I can take the simple one. Metal box should be taken. So we know that what is the formula for it? That is Q is equal to MC delta T over there. I want to calculate the C over there. That is Q over M, and also be taking as delta T. And Q is having its value 12,000 over M is 600 gram. It means that is 0.6 kg. And delta T is 45 minus 20 is 25. So if we go for its calculation over there, we can simply say here, okay, 12,000 1, 2, 3 divided by 0.6 divided by 25. So I'm getting here 800. So that is option D over there. Option D is over there. Let's move to question number 15 over there, where he is saying that a metal block is left overnight in a cool, shady room. In the morning, the metal block is removed into the warm surroundings. Okay. Which statement about the metal block is correct in the morning? The internal energy of metal block is increased. In the morning, the metal block is moved into warm surrounding. Okay. So it means internal energy of metal blocks is increased over there. At daytime, in the morning, it is increased. After that, no need to study others. If you have found the right option and you are sure about it, no need to study about that. A fixed mass of a gas contained within a sealed syringe at a pressure of 100 kilopascal. The plunger is slowly moved until the pressure is 80 pascal. The volume is 50 cm cube. The temperature does not change. What is the volume of the gas before the plunger is moved? So P1 V1 is equal to P2 V2 over there. P1 is 100. V1 I want to calculate over there. P2 is 80 and V2 is 50. So I'm taking 100 down. So 4, 8, 5, the 40 with 2 zeros over 100. So 2 0 cancelled. That is 40 cm cube. So 40 is that is 40 cm cube for option B over there is right. Let's go to 17th question. The diagram shows the more energetic water molecules are escaping from the surface of liquid over there of water. Okay. Which process is this called? Means high kinetic energy molecules are leaving the surface. That is called evaporation. By definition, we know that high kinetic energy molecules leave the surface as giving the cooling effect of the remaining molecules over there. And a hot object emits thermal radiation. A hot object emits thermal radiation. Okay, which row describes two changes that both reduce the rate of emission of radiation. Surface area means should be decreased over there. If I decrease the surface area, if I decrease the surface temperature, then radiation rate will be decreased. So I go with the option D over there. After that, number 19, he is saying the frequency of the wave is doubled. The period of the wave does not change. The speed of wave does not change. What happens to the wavelength of the wave? So V is equal to F lambda relationship. If I go for that, then I can say here V is equal to F lambda and V is constant. Speed is constant. What happens to the wave? Speed is doubled. Like frequency is doubled, means 2F lambda is equal to V. So if I make subject to this original lambda over there, then I say V constant over 2F. So it means it gets half over there. For number 20, he's saying which statement about ultrasound is correct over there. Then we say it has higher frequency than audible frequency range. Okay, he's right. And it is a longitudinal wave. Yeah, that's fine. Option A is fine for it. Longitudinal wave and have higher frequency than audible frequency range over there. Which statement about the image produced by a plane mirror is not correct? Image is real. Yeah, this is not correct. Image is upright is correct. Image is of the same size as the object, right? The distance from the image will be same as right. He is right. So according to this option, not correct. So this is going to be A over there. After that, 22, a ray of light is incident on a boundary between air and water. Under which conditions is the ray of light is totally internally reflected over there? Okay. The ray is initially in air and air-water boundary at angle of incidence. No. The ray is initially in the air, is incident versus no, greater than critical angle no, and incident and original total internally reflected. The ray initially in the air, incident on air-water boundary at an angle of incidence greater than critical angle over there. No. The ray initially in the water is incident air boundary angle of incidence. No. The ray initially in the water is incident on water air boundary at an angle of incidence greater than critical angle. So option D is fine for it. According to definition of total internal reflection over there. A converging lens is used to make an image on screen over there. Which type of image is formed on the screen? So converging lens is there, candle is placed over here. Then we can say which type of image will be produced on the screen. So I will say here that it will be real, it will be inverted. Yeah, this is the main characteristic of the image because object is on this side, image is on this side of lens over there. And if they are coming on opposite side, it means image is real and inverted. Real and upright will never form over there. Virtual and inverted will not be formed. Virtual and upright should be on the same side over there in the lens cases in explanation of there. And negatively charged rod is brought near to the sphere. And here he is saying a positive charge develops on the surface of metal sphere closest to negatively charged rod. Why is this? Electrons in the sphere are attracted by negatively charged. Electrons are not going to be attracted to negatively. Electrons in the sphere are repelled by. Yeah, that's fine. Electrons are negatively charged by themselves and they are repelled by negatively charged rod over there. After that, he is saying towards the electromotive force of cell is defined in terms of which quantity? The energy transferred by the cell in moving charge around the circuit. Yeah, that's fine. The energy transferred by the cell in moving charge around the circuit. Yeah, it's fine. After that, number 26, a resistor R is connected to a battery with electromotive force V. Okay. There is a current I. Power is dissipated in the circuit. Is time T is the energy dissipated. Which expression will be used as a correct formula for it? Then we can say it is, if I want to show there, power is equal to work over time. If I take this work as to be multiplying with multiplying by Q over Q, and then I'm taking this expression as W over Q multiply Q over T. Then it is VI and it is power. And when I'm taking the general formula, how to take the energy over there, then I'm multiplying T on both sides, and then I'm getting the electrical energy over there. That is VIT should be taken like this. Okay, a copper wire has length 80 centimeter, cross-section area this has resistance R. What is the length of the copper wire of cross-sectional area 0.40 millimeter square has the resistance this? Which length of copper wire? Okay, it means I will have to use the relation over there. R is equal to rho L over A. I am taking here rho is as it is. L1 over A1 is equal to rho L2 over A2 over there. Okay. And he is saying a copper wire of length 80 centimeter, cross-sectional area 20. Okay. So 0.20 like that. 80 over 0.20 is equal to, I need A2 is given already, 0.40, and I want to calculate L2 for it. 0.4, 0.2 to the 4, 8 to the 16, and area is given now. 0.40, 0.20, 0.40 is going to multiply and 8 divided by rho L over A. A copper of wire 80 centimeter. It is 80. Okay. And 80 is to 160. So option D is there. Okay. I was just missing with 0 over there. So I was a little bit confused what happened with the values of the answers over there. Four identical resistors are connected to a battery as shown. Each resistor has a value of 120 ohm. 120, 120, 120. Our resistor R4 is removed, which effect means in parallel as I remove the resistor means resistance increasing over there, which effect does moving this, like when they are connected in R1 is seriously connected with these three parallel. When they are connected with these two parallel, it means its resistance is decreasing, voltage drop across R1 is increasing over there. Then I can say here the effect of resistance does not change. No. Effect of resistance decreases by 20 ohm. No. The effect of resistance, the effective resistance increases by 20 ohm. Yeah, it increases because this one is removed and the remaining this one is going to increase its effect over there. After that, he is saying here for 29, the resistors in a circuit shown are identical. Okay. 1, 2, 3. These two are should be added and it should be subtracted over there. The reading on voltmeter is 1.5 volt. Okay. 1.5 volt on the voltmeter V2. Okay. And the reading on ammeter is 0.50. Ammeter A2. Okay. A2 ammeter is here, V2 voltmeter is here. Here it is, the reading is 0.50. Here is the reading is 0.25. And what is he saying over there? What is the reading over ammeter A1? Means both should be added 0.75 and voltage 1.5 should be added with 1.5. So as he said, all of these are identical resistors over there. So we can say here it is going towards 0.75 and 3 mm. Okay, both currents are added and voltage is 1.5 is here, 1.5 is the for the other resistor, and I'm getting total sum as 3 over there. After that, number 30 he is saying over there, and okay, a wire is moved in a region between the poles of magnet. A current is induced in the wire. Or okay, wire is downward having direction of current over there. In which direction in the current is the moving over there? So horizontal to north pole, no. Horizontal, no. Perpendicular is okay. Into the plane of the paper. Into plane of the paper. Yeah, it's right. Into plane of the paper. A fixed resistor is connected to the secondary coil of the step up down transformer. Okay, it means the secondary number of turns are less. The transformer is 100% efficient. The variable resistor is adjusted by this one, and so that the current is fixed. Resistor decreases by 0.25 ampere. What is the change in current over there? So what is the change in the current in the primary circuit? 0.25, it decreases by 0.25 ampere. Fixed resistor hai or 100 and it is 100% efficient. So I will say here it decreases by less than 0.25 ampere because it is going to step down over there. An electrical device changes the voltage of an electrical supply from 240 volt AC to 2. Awesome. Thank you. 240 volt AC to 20 volt to 20 volt AC over there. It means it is a transformer because it is doing a step down activity over there. So it is should go with the transformer because transformer can be step up and step down in that case. An AC generator is set up. Okay. of the wire for perpendicular to the magnitude of the magnetic field. The coil of the wire is rotated slowly to produce alternating EMF. Okay. And alternating EMF, a graph again, this which section of graph represents a rotation of 3/4. So 3/4 is, this is the half quarter, this is the full, this is 1/4, 2/4, 3/4. This is the 3/4, this is OR. After that, he is going towards here that this, uranium 92-238, thorium by emitting an alpha particle, thorium decays to plutonium by emitting beta particle, which row describes the atomic number and mass number of isotope of protactinium. Thorium decays to alpha particle. Okay. First of all, 92. Alpha particle emitted to thorium. So that is 90. After that, beta decay. So it should go with the increase of one atomic number, means beta is decaying over there. Then it should be 91. So that is this one. Why I am saying not going towards the 234 to check down? Because 238 is emitting the alpha particle, 4 mass is decreased, and 234 is fine. Let's go to the 35 question number. Which row shows what happens when a nuclear decays by emitting alpha particle? A neutron changes, neutron goes, changes, a proton changes, a proton changes. A proton changes to a neutron. No, a neutron changes to a proton and electron over there. So neutron will change to proton and electron. So overall, a new atom produced will not be affected by its charge, and particle emitted is beta form over there, and atomic number is increased over there. Which precaution does not always reduce scientist exposure when working with the source of ionizing radiation over there? Then we say ensuring the scientist only works with source of radiation that have long half-lives. Yeah, it's good. Means decay is when long half-life is there, rate of decay, rate of emission of radiation is very low, and we can take it into account over there. Okay, after that, number 7, a detector is placed near a radioactive isotope for a count rate of 700 counts per minute. The half-life is 8 minutes. The background is 60. So first of all, 700 minus 60 is there. And you are going to count rate measured by detector after 16 minutes. I will have to go for that. Okay, 640, then it is 320 added by 60 back as background, then that it is 380. 380 is not there. Why? What is the count rate measured by the detector after 16 minutes? First half-life, 8 minutes. Okay, 320 to go for more. Divided by 2 also, and that is 216. 160 is adding with 60, then it is 220. Yeah, it's fine now. Not to take 3 after first half-life, go for second half-life also. So it is 220, 37 as a D over there. The nucleus of an isotope of nitrogen absorbs a neutron. Okay, neutron is absorbed. And he is saying that it is going to show it is a decay an isotope of carbon. Means atomic number is decreased by 1. Okay, means 1 proton is lost over there. Because mass number is not changing over there. Only proton is lost, and neutron is going to balance over there. 1 neutron is being adding over there. 1 proton is lost in the form of this X particle over there. After that, he is saying over here, the graph shows how the strength of Earth's gravitational field varies as the distance from the Earth's surface increases. Okay, the strength of Earth's gravitational field is decreasing as distance from the surface is increasing over there. Then he is saying basically that which row describes mass of object should be remain unchanged over there. All right, and weight of object decreases because G value is decreasing. Option C is fine for it. Okay, A student plots a graph of different speeds of galaxies moving against their distances from the Earth over there. Distance is here and speed is here. Use the lost straight line to show the graph. What is the possible value of Hubble's constant? If you memorize that value exactly, then it can be easily remembered that 2 multiplied 10 is power minus 18 should be fine that. Okay. Otherwise, you can get the gradient on any 2 points over there, and you will get this value over there. And this was our paper, which was related to IGCSE February, March 2025, paper 2, variant 2. And always remember that there is only variant 2 paper is going to happen. Variant 1 and variant 3 papers are not happening in the February, March sessioning over there. So this was the solution. Kindly revise the video and subscribe my channel also, so that latest papers solution can be obtained with the proper explanations should be handed over to you. Thank you so much for today, and see you in the next video also.